Assalamu alaikum warahmatullahi wabarakatuh. Dear students, in this session I'm continuing my discussion from our previous sessions related to multiple linear regression model, where we have covered some very much basic and important elements of the output of regression, if you remember. So we have covered the concept of multiple R and the coefficient of determinations, which is R square. Also we have discussed in greater detail the concept and idea of adjusted R square, and also the standard error of estimates or the standard error of residuals. In this session, I'm particularly discussing the concept of hypothesis testing in multiple linear regression analysis, dear students. So first you should learn this is MLRM, and MLRM is a model where we have many independent variables. In our situations, we have three independent variables, and they are grants, FDA, and agriculture. And I'm just interested to know how each independent variable is affecting the dependent variable, which is GDP per capita in Afghanistan, students. So simply, what is the individual effect of each variable, and what's the combined effect of all these variables on the dependent variables, which is GDP, students. Okay, so the data I've collected simply from the World Bank, and this data set is really not enough for our analysis because technically the degree of freedom that SOL is 20 observations technically is not allowed for this kind of analysis. But just for the purpose of learning, I'm just using this data set, dear students. Okay, in case of multiple linear regression analysis, dear students, when we have hypothesis testing, then that's just divided into two types. One, we have the hypothesis of overall significance, right? Simply. And second, we have the hypothesis of individual significance. Okay. Dear students, the concept behind is very clear. In hypothesis of overall significance, we are just checking whether at least one independent variables we have in our set of variables that is just affecting the GDP significantly or not, right? Okay, more technically, you can say at least one beta, one coefficient that is technically that is significantly greater than zero in our model or not. So if you have at least one coefficient which is significantly greater than zero, students, you can say the model is significant overall. Okay, first you should know what are the hypotheses here. Okay, so the null hypothesis in case of hypothesis of overall significance, students, simply you can say the beta 1 that equals beta 2 and that equals beta 3, right? And that equals beta 4 and beta 5, and that finally equals beta k, and all of these coefficients simply, dear students, equal 0, right? What does this really mean, dear students? In null hypothesis, we say that the beta 1, right, and the beta 2, the beta 3, and all of these coefficients we have in the model, they are equal 0. It means there is no relationship between these variables, between the dependent variables and independent variables, right? Simply, why? Because if the beta 1 technically is 0, it means the grant does not have any effect on GDP. Or if the beta 2 is 0, why? Because any value multiplied by 0 is equal to 0. So FDA is having no effect in case if the beta 2 is 0. So if all coefficients we have in a model that equals 0, it means there is no significant relationship between between variables in the model we have, dear students, okay? Between the dependent and independent variables, dear students. Okay, what is our alternative hypothesis? Simply, it's just looking like this. You can say at least one beta, right, that is greater than 0. Okay, dear students, once again, I'm just repeating. In hypothesis of overall significance, we are just checking whether at least there is one independent variable, right, that is just significantly affecting the dependent variables. In technical way, you can say at least there is one coefficient or beta that is significantly greater than 0, right? Then we are rejecting the null hypothesis and we are claiming that our model is significant overall, right? Okay, so for testing this hypothesis, simply we have a test by the name of f-statistics, right? And that equals the function is just a mean square of regression, right? And that should be divided by the mean square error. Okay, when you find out the f statistic value, and that is less than significance, the significance level of 0.05, 0.05, then we are rejecting the null hypothesis, right? And claiming that yes, the model is significant overall. Once again, dear students, in hypothesis of Wall's significance, we are just checking that at least there is one independent variable that is significantly affecting the dependent variables. So if you found out that yes, there is one beta that is significantly greater than zero, right? And that is only possible if the F statistic value is less than 0.05, then you can reject your null hypothesis and claim yes that the model is at least significant overall. So it does not really mean that one beta is just greater than zero. If we found out that the model is significant, it means at least one beta is greater than zero. Maybe there are many more coefficients that are greater than zero. Maybe there are many more independent variables, right? They are significantly affecting the dependent variables. Okay, now in the second part here, students, we have the hypothesis of individual significance. Okay, if in the first part we found out that at least one beta is just greater than zero, then there is logic behind just to do the analysis of the second part, right? In the regression analysis. But if you found out that the at least one beta, there is no any single beta that is just significantly greater than zero, then in that situations, when you fail to reject the null hypothesis, then there is no logic behind just to come down and do the analysis of the second part. Then you should stop there. Why? Because if your model is not significant overall, it means there is no any effect, no any variable we have in the model is just significantly affecting the GDP. Then there is no logic behind to do the analysis of individual variables in this section of hypothesis of individual significance, dear students. Inshallah, I'll see in regression output. Okay, so what are the hypotheses of individual significance? Okay, we should develop the hypothesis for all variables. So first we should develop for grants, and for grants you can just type and write that the H naught, that is grants, has no effect on the GDP per capita, right? And the alternative hypothesis, you can say the grant has a positive effect on the GDP per capita. Okay, this is the first hypothesis. Similarly, you should develop for FDA students, right? And the null hypothesis for FDA is just, you can say the FDA has no effect on the GDP per capita of Afghanistan. And you can say the null hypothesis here that the FDA has a positive effect on the GDP per capita of Afghanistan. Okay. Next, for the third variable, you should develop, right? We have agriculture, and similarly in the same manner, you can say the null hypothesis here, the agriculture has no effect on the GDP per capita. And you can say here the alternative hypothesis that the agriculture has a positive effect on the GDP per capita. Okay, dear students, the logic behind is very clear. Here in grants, in null hypothesis, we say that the beta equals the beta of 1, in this situation that equals 0. And here we say the beta 1 that is greater than 0. This is what we are just trying to test, okay? And here we say the beta 2 for FDA, that is the coefficient of FDA, that's equal to 0, right? And the alternative hypothesis, we claim that the beta 2 is just greater than 0, students, okay? In the agricultures, we say the beta 3 that equals 0, right? And in our alternative hypothesis, we just claim that the beta 3 that is greater than 0, students. Okay, once again, I'm just concluding. In case of hypothesis of overall significance, if you found out that there is no at least one beta that's significantly greater than 0, and you fail to reject the null hypothesis, it means the model is not significant overall, and there is no need of the analysis for these independent variables. Just stop there, right? Why? Because if beta 1, beta 3, and beta 3, in all of them, all these coefficients equal 0, it means all of these independent variables, they are not significant, and that's suffice. That's enough. The analysis just stop there in case the model is not significant overall. Okay, now practically I'm just showing this, dear students, in the regression output. Look here. Okay, click here, run regression from the data, click on the data analysis, and we have regression, dear students, and here choose your dependent variable, and that is GDP simply. That's already selected. And our independent variables, we have 3 independent variables, right? Okay, just click on the labels and the confidence level simply, dear students. Why? Because we are rejecting the null hypothesis under the significance level of 0.05. So that's why we are choosing the 95% confidence interval. And I'm just choosing this place for the output, okay? Okay, dear students, this is the regression output. Okay, the first element I'm just analyzing in this output, dear students, that is the F test, are the hypothesis of overall significance. So I'm just copying this data, right, and moving it down. Okay, okay, just here. I think it's enough here. Okay, dear students, look here. Okay, these 2 columns here are extra. Now, in this output, dear students, the F test simply, as I've told you that the F statistic is just computed, the MSR, the mean square regression, is divided by MSE. Okay, you know, we have explained the sum of square regression and the sum of square error several times. And so this is the sum of square regression, and this is the sum of square error, and this is the total sum of square, if you remember. Now, if you divide the sum of square regression by the total sum of square, that is just giving you the R square. And what is the interpretation of the R square here, students? Simply, you can say the R square here means that what is the total variations explained by these 3 independent variables. You can say 83.85% variations explained, right? So how it is computed, you can say the sum of square regression, this is the total variation. Simply, this is the amount of total variation which is explained by these 3 independent variables. When you just divide this value by the total variation, this is technically just giving you the percentage of the total variations, and this is what is called coefficient of determination, what we have already explained. And this is, the students, this is the residual. This is the area which is not explained, right? This is the area which is explained in the model. And if you remember, once again, I'm just giving you a quick review right here. Okay, look, this is model, right? And this is our x. This is x is our independent variable, and this is our dependent variable, students, right? And this is simply the slope. Now, if, for example, this is the average line, right? Now, this point, dear students, this one, this is, you can say, this is y bar, right? And this point, dear students, this is, you can say, this is y hat, which is estimated y hat, right? And this point, dear students, you can say this is the y actual, yi, right? Simply, this is the y bar, this is y hat, and this is y actual. So, dear students, this is the area which is simply explained. This is explained area, and this is the area which is not explained, right? And this is the area from this point up to this point. This is the area. This is the total area. This is the area. This is the explained variation, right? From the average up to the y, this is the explained variation. This is not explained. So whenever you divide the area which is explained by the total area, right, that is just giving you the sum of square, that is just giving you the coefficient of determinations. So simply, this is the area which is explained, right? This is the area which is explained, and this is the area which is not explained. Okay, now I'm just asking you a question. Now, if we have 3 independent variables, and this is the area which is explained by these 3 independent variables, or you can say this is the total variations due to these 3 independent variables, which is grants, right, FDI, and agriculture. Now, what is the average variations happened in our analysis because of 1 independent variables? Okay, or you can say what is the variations, right, in our dependent variables due to 1 independent variable? What is the average variation? So we have 3 independent variables. Simply divide the total variations and the number of independent variables, that is just giving you the mean variation. Simply you can say each variable by average is just bringing this much change in the dependent variable, or you can say each variable by average is just changing, right, affecting our GDP per capita by this much amount. Okay, this is the total area which is not explained, and the number of residuals, right, or you can say the number of actual points or errors we have, that is 16. So now when you divide it by 16, so this is the average error, or this is the average variation which is not explained, dear students, simply. Okay, now for the function of f statistic, dear students, we are dividing the mean square regression by the mean square error. So first you have learned that how the mean square regression is just computed. So simply for the mean square, the sum of square regression is divided by 3, is just giving you the mean square, and sum of square error is divided by 16, that is just giving you the mean square residuals. Now when the mean square regression, this value is divided by the mean square residual, that is just giving you the f value, dear students, right? That is the way you can find it out here. Now once you find out the f statistic value, dear students, then you should compare it with the significance f values. In our situations here today, look, we have the significance value that is less than 0.05. So actually what is this value? This value is 0. You can say this is 0 point. And then you should, after the points, then you should have how many decimals? Up to 5. So you can say 1, 2, 3, 4, 5, and then you should start from 1, 1, 4, 3. So this is just, this is the value. So this is, you can say the f value that lies in the normal distributions curve under the significance level of 0.05. So this is really below 0.05. That's why we can say yes, we are rejecting the null hypothesis. Why? Because the f value is way less than 0.05, and that's why we are claiming that the model is significant overall. And once you get this result, then you just come down, and now we are just comparing our other results. Okay, look, dear students,